Hello, hello. This is Postgres FM. I'm Nik, Postgres AI, and as usual, with me here is Michael, PG Mustard. Hi, Michael.
Hello, Nick. How's it going?
Very good. How are you?
I am good, thank you.
We haven't recorded last week because I was on trip in Oregon forest, having some fun, disconnected from internet mostly. Yeah, so now I returned and you said we should discuss sequences somehow, right?
Yeah, so I was looking back through our listener suggestions. So we've got a Google Doc where we encourage people to comment and add ideas for us to discuss topics. And whenever I'm short of ideas, I love checking back through that. And one of them from quite a long time ago actually caught my eye, and it was the concept of gapless sequences. And I guess this might be a couple of different things, but I found it interesting both from like a theoretical point of view, but also in terms of practical solutions, as well as being one of those things that's kind of so a sequence with gaps is one of those things that catches most engineers' eye. Like if you start to run a production Postgres, you will see occasionally like an incrementing ID and then a gap in it, and you think, what happened there? So it's one of those things that I think most of us have come across at some point and been intrigued by. So yeah, there's a few interesting causes of that I thought we could discuss.
The name sequence should mean it's sequential, like why the gap, right? Unexpected. And by the way, this episode, is it number 163, or because I missed last week, it will be 164?
Do you know what? It would be quite funny to. Should we increment the
Yeah, we also remember because I was telling, yeah.
Either we should do 164 missing one and then do 163 next week as like a joke and like because it's like coming in too late, or we just carry on
the order is broken. This is another anomaly you can observe sometimes because at commit time you can see like if we have many users, they can use next numbers from sequence all the time, and then at commit time the order is not can be different, of course, right?
Yeah, I forget the name for it, but whatever that phenomenon is, we should discuss that next week and have the ID go down.
It's not serializable, right? So it's it's not serialized. So if you have two transactions and one, for example, you have support system ticket tracking system, and you generate ticket numbers, you think sequentially. One user came, opened a ticket, but hadn't committed it yet. Another user came, opened ticket, and that ticket has bigger number, next one, right? And then committed already, and then you committed this, so you see one ticket created before that one, right? But at the same time, if you generate timestamp automatically with like created add column with default clock timestamp or something, and it was insert happened at the same time when sequence next val call happened. In that case, created add values will have the same order as sequence values, like ID column values, right? So there will not be a problem when you order by those tickets. But anomaly can be understood. There is a ticket number like 10 and then number 9 visible later because we don't see uncommitted writes, right? So it should be committed first before it's visible to other transactions, other sessions.
Yeah.
But this is different anomaly, like gapless gaps. This anomaly is very well known because for the sake of performance, sequence, this mechanism in Postgres exists for ages, and it just gives you next number all the time. And of course, if you, for example, decided to roll back your transaction, you lost that value. So
yes.
This is number one thing.
Yeah, exactly. So it's to allow for concurrent writes, isn't it? So if you've got, imagine it like within a microsecond, two of us trying to insert to the same table. If I am just before you and I get assigned the next value in a sequence, and then my transaction fails and is rolled back, you've already been assigned the next value after me. So yeah, I think that's super interesting. So I think that's probably the most common. In fact, well, possibly not, but that's the one I always see as the example given as to why.
Yeah. So for not to think about going back to previous values. Like this is your value, and it's like fire and forget. Like this value is wasted, and sequence has shifted to new value. Although you can reset it using there's next val and there's
set val. I think
there is car val, and car val requires assignment first before you can use it, and then set val. Yeah, so you can shift sequence back if you want, but it's global for everyone, right? And also interesting, sequence is it's considered relation as well, right?
Yeah, we discussed this recently, didn't we?
Yeah. In PG class, you see rel kind equals you said capital S, right?
Capital S. And by the way, I was wrong. It's not the only one with a capital.
Okay.
There is one other. Do you know the other one?
No.
Indexes on partitions.
Okay.
Capital I.
Okay.
So we've got one cause already you've mentioned, which is transactions rolling back. I want to go through a bunch of other causes, but before that, should we talk about why would you even want a gapless sequence? Like what we've got sequences, and sequences with the odd gap in are fine for almost all use cases. Should we talk a little bit about why even bother? Like why even discuss this? Why is it a problem?
Well, my expectations, I guess, right? You might have expectations.
So I think I've only got a couple here. I'm interested if other people have seen others. But one I've got is user visible IDs that you want to mean something. There was a really good blog post on this topic by some folks at instant.io. It's actually old friends of mine from Go Cardless days. And they wanted instant IDs to increment by 1 for their customers. So they could refer to an instant ID, and if they've had 3 that year, it's up to 3, and then the 4th one gets assigned incident 4. And it's not ideal if they want them to mean something for them to miss the odd one, and much worse to miss like 10 or 20 in a row.
So they obviously have many customers, so it's multi-tenant system, right?
Yeah.
And do they create a sequence for each customer?
Well, they did initially.
Okay. Yeah, I'm asking because I saw this in other systems, and I remember the approach when we have a sequence just to support primary keys, unless we use beautiful UID version 7.
Yeah.
Well, with some drawbacks, but overall it's winning in my opinion these days. But for each customer, like in namespace of each client ID or organization ID, doesn't matter, project ID, we might want to have internal ID which is local, right? And then we shouldn't use sequences. It's like overuse of them, because if each customer has like thousands or millions of rows, and like we can handle it, and collisions would happen only locally for this organization or project or customer, right? Which is great. Yeah, right. So yeah, and for sequences, we just the only thing we care about is uniqueness, in my opinion.
Yeah, you're right. Uniqueness but that's the job of the primary key, right? It's also the fact they only go up, I think. Is
Well, unless somebody rewind, right, with
set val.
Set val, exactly. So. And the capacity, just forget about it, because it's integer 8 always for any sequence. So I noticed some blog posts you share with me, not this one, different ones. They used integer 4 primary keys. I very welcome this move, because these are our future clients.
Oh, no.
Yeah. So very good move. Everyone, please use the integer 4 primary key, and later, if you're successful and have more money, you will pay us to fix that. Yeah.
I like you flipping the advice. So wait, but you said something interesting then. So you said sequences are always integer 8. So even if I have an integer 4 primary key, the sequence behind it is integer 8.
Sequence, it's an independent object, which, independent relatively, because there is dependency, which is also a weird thing, like owned by, right? It belongs to, it might be dependent, but it also might belong to a column of a table. Yeah, with alter table, alter sequence owned by some column, right? But overall, it's just a special mechanism. Integer 8 always and just gives you a next number. That's it. Simple.
Yeah. So yeah, by the way, I wasn't talking about, so Instant.io did use sequences initially, and it turned out to be a bad idea. But all I meant was that that's a use case for not just monotonically increasing IDs, but IDs that increase by exactly one each time. So that's one use case for like the concept of gapless sequences. And another one came up in the blog post by Sequin that I shared beforehand, and I'll link up in the show notes again. And that was the concept of cursor-based pagination. So the idea that I think it's very similar to key set pagination, but based on an integer only. So the idea that I guess for those it's most important that it only increases, but also that concept of the committing out of order becoming important. So if we read rows that are being inserted right now, there might be one that commits having started later than a second one having started earlier than a second one that hasn't yet committed. So we could see, the example they give is we could see IDs 1, 2, and 4, and later 3 commits, but we only saw 1, 2, and 4 at the time of our read. So if we were paginating and got the first set and it went up to 4, and then we only looked for ones above 4, we've missed 3. So that's an interesting definition of a sequence where you don't want there to be gaps, maybe at any point.
You know what? I'm looking at the documentation right now, and I think it would be great if this thing called not sequence but something like generator, a number generator or something, because sequence, it feels like it should be sequential and gapless, like it's just some feeling, you know. This just gives false expectations to some people, not to everyone. Of course, the convention says create sequence, define a new sequence generator, right? So generator is a better word of this, right? And I think documentation could be more explicit in terms of gaps to expect.
Yeah.
Yeah. So yeah, because in my opinion, in practice, it happened not once when people expected them to be gapless somehow. I don't know. Like a lot of new people are coming to Postgres, and
all of us were new once, right? As well. Like I definitely experienced this. I remember. I think for us, moving on to kind of a second cause of this, I think the reason we were getting them was using insert on conflict. So if it was something around having new users that had been added by somebody else in the team, for example. So the user had already been created behind the scenes because somebody invited them, and then when they signed up, we were doing an insert on conflict update or something like that. And then, so as part of that, the next file was called just in case we needed to insert a new row, but we ended up not needing to because it was an update instead. So I think you can get these again through insert on conflicts.
Yeah, and actually the documentation mentions it about.
Oh, cool.
It mentions it, like I think still could be mentioned more explicitly, maybe in the beginning and so on. And the thing is like someone might consider sequences as not ACID, right? Because if rollback happens, they don't roll back. And for the sake of performance, obviously.
So it violates atomicity, does it?
Yes or no? Yeah. So if other rights are reverted, this change that we advanced sequence by one, right? We shifted its position. It's not rolled back. So yeah. So our operation only partially reverted. If we strictly look at it for the sake of performance, it's pretty clear. But yeah, so like kind of not full ACID, and that's okay. It's just you need to understand it, and that's it. Yeah, and for me it's natural, but I can understand the feelings of people who come to Postgres now and they just from the name they expected it, but then boom. It's a simple thing to learn. Yeah.
Yeah, another case where naming things is hard, and
right.
Yeah.
So yeah, for me it's a generator of number. Huge capacity, 8 bytes, and it gives me a tool to guarantee some uniqueness when we generate numbers. That's it. very performant. Very, very. I never think about performance because rollback is not supported. That's it. Let's go. And yeah, but let's talk about again, like, if we really need it. I would think, do we really need it, or we can be okay with it? If we really need it, I think we should go with like specific allocation of numbers, maybe additional ones, not primary keys, right? Right.
Yeah, well, personally, I think this is a rare enough need that it's not needed by every project, I don't think.
Right.
I've run plenty of projects that have not needed this feature. So I personally think there's not a necessity to build it into Postgres core as a feature, as like a sequence type or something. But I do think it's interesting enough, like it seems to come up from time to time, and I think there are neat enough solutions, at least at lower scales. I'm sure there is a solution at high scale as well, but there are simple enough solutions at lower volumes that I think there's no necessity, I don't think, for a pre-built solution that everyone can use.
High performance solution. It's impossible, because if there is transaction which wants to write number 10, for example, but it hasn't committed yet, and we want to write next number or also number 10, it depends on the status of that first transaction. We need to wait for it, right? It creates natural bottleneck.
Yeah.
And we like, I cannot see how it can be undone, right? Like, can be done differently. We need to wait until that transaction. We need to serialize these writes. And again, like, for me, the only trick in terms of performance here is to use the fact that if we have multi-tenant system, we can make these collisions very local to each project or organization or tenant, right? So they compete only within this organization, and the other organizations are not are separate in terms of these collisions.
And ultimately, then it's about parallelizing writes, which I think is then sharding.
Yeah.
So if you've got the multi-tenant system across multiple shards, you can then scale your write throughput. So it feels to me like another case of that probably being the ultimate solution.
Well, if you involve sharding and distributed systems, it's like...
I don't mean unique across shards. I don't mean
locally.
Exactly. If you've got a tenant that's local and you can...
Because if you want pure sequential gapless number generator for distributed systems, it's a whole new problem to solve. You basically need to build service for it and so on. But again, if we make... so you should think about it. Okay, we will have thousands of writes of new rows inserted per second, for example, soon. What will happen? If the collision will happen only within boundaries of one tenant or project organization, doesn't matter. It's not that bad, right? They can afford inserting those rows sequentially one by one, and maybe within one transaction, or some transactions will wait, but maybe just one. So maybe this will affect our parallelization logic. So saying, let's not deal with multiple tenants and multiple backends and transactions. Let's do it in one transaction always. But if we write thousands of rows per second, and they belong to different organizations, the collisions won't happen, right? Because they don't compete. So this dictates how we could build this high-performant gapless sequence solution. We just should avoid collisions between tenants, for example. That's it. Yeah.
But we've jumped straight to the hardest part. Should we talk about a couple more of the kind of times that you might see
surprises? Yeah. So rollback is one thing which can waste your precious numbers. Right. Right. Another thing is I learned about it and I forgot, and later on when you sent me these blog posts, there is a hard-coded constant 32 pre-allocate.
Yeah.
Actually, I think there is constant, and I think there is some setting. Maybe I'm wrong, but there should be some setting.
A duck.
Yeah, so which you can say I want to pre-allocate more.
Oh, I didn't come across that. So we've got set log vowels. That's the hard-coded one, right?
Yeah, maybe I'm wrong, actually. So there are pre-allocated values. And can we control it? No, we cannot control it, right? 32. There is cache, right? What is cache? when you create a sequence, you can specify the cache parameter as well.
Oh, okay.
Right.
So what does that control?
Yeah, so this controls exactly like this. If you don't do it, it will be 32.
Oh, okay. So
But
it's definable on a per sequence
per
basis.
sequence, you can say I want 1,000 pre-allocate.
What if we set it to 1?
Well, I think only one will be pre-allocated, right?
Or 0?
One is minimum actually. So yeah.
1 is minimum.
Yeah. Actually, it's also interesting. Maybe I'm wrong because there is also, yeah. So I'm confused. There is so documentation about this parameter says 1 is default, but we know there is also 32 hard-coded constant.
Yeah.
In any way, like I know this hard-coded constant can be associated with 32 gap. So when, for example, failure happens, or just you fail over, switch over to new primary, which should be like normal thing, right? You change something on your replica, switch over to it. This is when you might have a gap, which is described in one of those articles, 32. So I'm not sure about this cache parameter, right? So maybe if you change it, it's only cache of pre-allocated values and that's it. Maybe like specifying it won't lead to bigger or smaller gaps. I'm not sure about that. So maybe there are two layers of implementation here. But based on articles, we know that, okay, there are gaps of 32. And this is like just like common, right? And interesting, this is connected to recent discussions we had with one of big customers who have a lot of databases. And we discussed major upgrades. And a part of, we have zero downtime, zero data loss, reversible upgrades solution, which multiple companies use. And part of it is like one of the most fragile parts is when we switch over. During switchover into logical replica, we do it with basically without downtime thanks to pause, resume, and pg bouncer. Also pgdoc supports it. So we pause and resume. And between pause and resume, where small latency spikes in transaction processing happens, we redirect pg bouncer to new server. And that server by default has sequence values corresponding to initialization. Because the logical replication in Postgres doesn't support still, there is work in progress. I think it's close to. It doesn't replicate values of sequences. So the question is how to deal with it. There are two options. First, you can synchronize sequence values during this switchover, but it will increase this spike. We don't want it because we achieved a few second spike. That's it. It feels really pure zero downtime. And if we start synchronizing sequences, it will increase it. Especially some customers had like 200,000 tables. It's insane. But okay, if it's only 1,000 tables, I thought, well, I don't want it. Actually, customers said, one of engineers on customer side said, you know what, like this set val is not too long. If we quickly read it, quickly adjust it, maybe, okay, another second. And testing shows, yeah, exactly, like changing position of sequence is super fast, actually. Yes, if you have hundreds of thousands of tables and sequences, it will be quite slow. But it's only a few, you can do it quite quick. Also can parallelize it maybe, but it will make things more complicated. But another solution which I like much more, we just advance it beforehand, before switchover, with some significant gap. Like I say, check how many you spend during like a day or two, millions, 10 millions, advance. We have enough capacity for our life. 8 bytes, it's definitely enough. So yeah, just bump it to like 10 millions. But then it works with your system, like 1,000, 2,000 tables. It's just one system, and these big gaps are fine. But when you think about very, very different projects, thousands of clusters, you think, oh, maybe some of them won't be happy with big gaps. And this is a hard problem to solve. Yeah.
And if you go back in the other direction, let's say you want to be able to fail back quickly, that's another gap. So each time you bounce backwards and forwards.
Yeah. Yeah, since our process is fully reversible, it's really blue-green
Yeah.
deployments through blue. Every time you switch, you need to jump, and we recommend jumping in big, like we have big gaps, and like we say you should be fine with it. But I can imagine,
Why not smaller gaps? Why
yeah,
not why not like let's say it's a 2 second pause.
yeah. If you know there won't be spikes of right before you switch over, well, we can do that. But it's just there are like risks increase of
Yeah, of
overlapping.
course.
If you did it wrong, after switchover, some inserts won't work because this sequence already used, right?
Or duplicate
So
key or yeah.
yeah,
What
so
would the actual errors be? Duplicate key violations.
yeah, so
Yeah.
your sequence, but yeah, it will heal itself, right? Thanks to nature of sequences which like waste numbers. Insert like unique key violation, oh, it works. Yeah, it's funny. Yeah, anyway, like I was always like thought like I always prefer to be on safe side and jump in like do big jumps, but when you think about many clusters and things of many people,
Yeah.
oh, it's a different kind of problem to have, and so I'm just highlighting gaps are fine, but what about big gaps?
Yeah.
Sometimes it can look not good. It might look
Yeah.
not good. Yeah. In this case, yeah, we are still thinking maybe we should just implement two paths, and by default we do big jump. But if somebody is not okay with that, maybe they would prefer a bigger spike or bigger like maintenance window, like okay, well, up to 30 seconds or so.
Yeah.
While we are synchronizing those sequences and don't allow any gaps. Although for me, naturally knowing how sequences work for years, like gaps should be normal, right?
Yeah, it's so interesting, isn't it? Like the trade-offs that different people want to make. And it's
Solution to this?
yeah. Pardon me?
The good solution to this? Finally start supporting sequences in logical replication. That's it.
Yeah, that would be well. Yeah, and that might not be too far away. So yeah,
I
good
think
point.
so.
That'd
I
be
think
great.
so. This work in progress lasts quite some years. It's called logical replication of sequences or synchronization of sequences to subscriber. And it's already multiple iterations since 2024, I think. And it has chances to be in Postgres 19, but it requires reviews. It's a great point for you to take your Claude code or cursor and ask it to compile and test and so on, and then think about edge cases, corner cases. And even if you don't know C, this is a great point to provide some review. You should be just engineer, like writing some code, and you will understand discussion, comments. It's not that difficult. So I encourage our listeners to participate in reviews, maybe with AI, but there will be still value if you consider yourself an engineer. You will like figure it out over time which value you can bring. The biggest values in testing is to think about various edge cases and corner cases as a user, as Postgres user, right? And try to test them, and AI will help you.
Yeah.
That's
Well,
it.
I also think we do have several experienced Postgres like C developers
Yeah.
listening, and I think it's always a bit of a challenge to know exactly which changes are going to be the most user beneficial, because you don't always get a representative sample on the mailing lists. I think sometimes like a lot of the people asking questions are very they're like at the beginning of their journey. They haven't yet worked out how to look at the source code to solve problems, so you don't get some of the kind of slightly more advanced problems always reported because people can work around them. And I think this is one of those ones that people have just been working around for many years. A lot of consultancies deal with this in different ways, but it is affecting every major version upgrade. It is friction on. So if any hackers, any experienced hackers are also wondering like which changes could I review that would have the biggest user impact, this feels like
This feels like so many want it. Logical replication is used more and more, like blue-green deployments and so on. And it's like, for me, in the past, if I looked at this, let's include, by the way, a commit fast entry so people could look at it and think if they can review and help testing. So in the past, I would think, okay, to test it, I need, first of all, what I need. This is about logical replication and behavior. I need logical replication. Setting up 2 clusters with logical replication. Oh, yeah, okay. I have better things to do, actually, right? Now you can just launch your Cloud Code or Cursor and say, I have Docker installed locally on my laptop or something. Please launch 2 containers, Postgres, different versions maybe. Create logical replication and let's start testing. And then not containers. If containers work, now you can say, okay, now I want some of them are built locally from source code, and then same thing. And you don't need to install to set up logical replication yourself. That's it. So
True, good point.
Yeah. So this roadblocks can be eliminated by AI, and then you focus only on use cases where this thing can be broken, and this is where you can start contributing. You just need to be a good Postgres user. That's it.
Yeah,
good,
nice.
Good. Just to be able to distinguish logical replica from physical replica manually. This is the only thing you need to know to start. Yeah, good. Okay. So, are there any other cases where we can experience gaps?
Well, I actually thought I only wanted to talk about 2 more things for sure. One is why 32? Why do we pre-allocate these? I think that's interesting. And 2, what can you actually do about I thought the incident, especially at lower volumes, there's some neat solutions. They were the only last 2 things I had on my list.
Well, for performance we pre-allocate, right? Because technically it's a page, it's also a relation which stores value and so on, right?
Well, I got the impression from a comment in the source code that it was, so let me read it exactly. We don't want to log each fetching of value from a sequence, so we pre-log a few fetches in advance. In the event of a crash, we can lose, in brackets, skip over, as many values as we pre-logged. So I got the impression it was to avoid spamming the wall.
Yeah, it's optimization technique, that's it.
So I could imagine a case where you'd want to pay that trade-off the other way around, and it's good to know, as you mentioned, that you can reduce it on a per sequence basis.
I think it's different. I think what you can reduce is cache, but it's not the thing that goes to wall. I'm not 100% sure here. I just think you still will lose to 32. But because these are 2 different things. One is hard-coded constant value, another is dynamic controlled by user. So, but maybe I'm wrong again here. It's a good question to check. But it's nuance. Yeah, for me, sequence is always having gaps. That's it.
Yeah,
it's okay.
And then the last thing was solutions, and I thought the incident one was really neat, but also it's very, very simple. I like simple solutions that work for now, and we can solve later problems later. And it was just to do a subquery and read the max value currently and increment it by 1. So not using sequences, of course.
Yeah, no sequences, it's just reading. And it reminds us the episode we had with Haki Benita, right? And the problems.
Yes. Yeah.
Get to create or something like this, right?
Yes.
So we need to deal with we need to read the maximum value and get +1, but maybe others do the same thing in parallel, and how to deal with performance in this multi-concurrent environment. Again, the clue for me is to use to narrow down the scope of collisions. That's it. So contention would be only local to
So there's multiple options, right? You could just implement, I say just, as if it's simple. Retries are one option. If you expect collisions to be super, super uncommon, retries would be a solution. But I think the Sequin blog post actually goes into a bit of depth into how you could scale this if you are doing tons, a lot per second. So that's an interesting solution that is way too much code to go into now, but I'll link that up in the show notes.
Yeah.
But yeah, I did think there's a range of solutions, from we have a multi-tenancy system, like Incident, for example. You're not going to be creating hopefully most organizations are not going to be creating thousands of incidents per never mind second, per day. So the chance of collisions or like issues there are so low that it's almost a non-issue. Whereas for a different use case, I can't think of a use case for like needing a gapless sequence that can insert thousands or like thousands per second. So I just don't see that being a well, I'd love to hear from people that have seen that or have had to deal with that and what they did.
Thousands per second?
Yeah. And a gapless sequence, like
Yeah.
where it's important not to have gaps.
Yeah, because you have a lot, if you have a lot of inserts, you have big numbers, and
Right.
So the idea is gapless, desire to have gapless matters when we have only small numbers.
I think it's more important, right?
Yeah, maybe like
Also,
okay,
even
it was
32 would disappear quickly. Imagine a gap of 32. It would disappear quite quickly if you're
because if it's a big number, we already stop paying attention to. Yeah, maybe you're right.
And also, I don't think computers care about gaps. I think it's humans that care.
Yeah.
Personally, I don't know. Like,
Yeah.
it's an
Oh
interesting...
well, with sequences, I remember it was 2005-06 when we wanted to hide actual numbers of users and things created in our social network. So we used two prime numbers and set default next val from sequence multiplied by one big number and then modulo of different number. So it was like fake random, you know,
Yeah.
to hide it. I figure out like you can still, if you create several things yourself, you see numbers, you can quickly understand the logic, and like it's still, you can hack it and understand the actual growth rates. But it's hard to understand absolute value from this. You don't know how many things compared to like people who don't care. They just one global sequence for all users, and number of posts this like 1 million something. Okay, this platform has 1 million posts. It gives some signals to your competitors, right? So
I learned today what that generally is called. It's called the German tank problem. Have you heard this?
No.
It's like maybe not the first, but like the first famous case of this was, I think, in World War II. The Allies were using the numbers, like an incrementing number found on German tanks, to find out how many they were going through, like how many what their production capacity was, and it was a useful thing in the war. This is older than computers.
Yeah, it reminds me how the guys who from my former country went to your country to poison some guy, and their passports were sequential. That's how they were tracked. Wow. Yes. So stupid, right? I mean, sometimes gaps are good if you want to hide some things. Like, yeah. So if you build some system, maybe you want the gaps actually.
Yeah. That's the next episode, another different episode.
How to build gaps.
Gapful sequences, yeah.
Some random gaps, so everyone like doesn't understand how many.
Yeah, just UUID v4, right?
Yeah, random jumps. Anyway. Yeah, so that's it. I also wanted to mention sequences have create sequence has a few more parameters you can specify, like mean value, max value, and you can say it should be in loop. I don't know, like I never used it. Cycle, it's called cycle. So you can specify from 1 to 1,000 and cycle.
So you don't, for example, need to. It doesn't need to be on a primary key. So it couldn't be on a primary key, that one.
Yeah, I would use like just percent operator modulo, just divide by something and have the same effect. But
yeah, I guess it's similar to transaction IDs. If you think about how transaction IDs loop.
Yeah, wraparound. Yeah, if you want wraparound, go for it. Yeah, I'm very curious use cases for this. Never used it. Yeah, but in increment also you can specify jump in like only odd numbers, for example, right?
Yeah, or any positive might be more common.
We want to increment by random. This will be our random gaps to fool everyone.
Yeah. All right.
Okay. Good.
All right.
Enough about sequences. Thank you for the topic. Yeah.
Likewise, good to see you and catch you soon.
Bye bye.